All right. So that was one example. Okay, and that's the TVM solver. You know, it's a little bit easier, as you can see, because you're not like doing a big you're not using a big formula. So, all right. Okay, so let's keep doing. Let's do some more stuff. So let's do another example. So here we're going to use the formula. So here, let's assume we have 250,000. We want to have, excuse me, $250,000 in our account. Okay, let's say we want to have that when we retire in 30 years. Okay. Now it turns out the account we have, the retirement account, earns 8% interest. So how much do we need to deposit each month to meet this goal? Okay, well, notice we're looking for PMT here, right? We want the monthly deposit. That's what we're looking for. Okay, we're going to use the formula. So we're looking for PMT. R, the APR, that's 0.08, right? It's the interest rate as a decimal. And notice we're going to be making monthly deposits, right? So it's going to be compounded each month. Okay, monthly deposits, it's being compounded monthly. So N is 12. Remember, unless stated otherwise, it's compounded the same number of times we make deposits. We make monthly deposits, that's 12 times a year. It's compounded monthly as well, 12 times a year. T is 30 years because that's what we're given. We're given that. And we want A to be $250,000. So A is $250,000, right? So we want to know what PMT is. We're going to solve for that. Okay. So here we plugged everything in. Okay, as you can see. Good. Okay, now what do we want to do? Well, again, we want to solve algebraically for PMT. What I did here was I multiplied both sides by 0.08 over 12, and that's how I got the line below it. So I got the line below it here. Okay. You know, essentially, I didn't show the calculation, but hopefully everyone can see it. Actually, you know what? Let me see if I can do it in red ink. I'll try. 0.08 over 12. Okay. We do the same thing over here. Like so. So this is going to cancel. And what we get is this. I mean, I put it over here, but again, you can multiply in any order you want. Okay. So we're here now. And now to go from here to here, okay, what we did is we divided by this. I mean, I'm not going to write that in pen, you know, on the slide that is, but we divided both sides by this. That's how I got this. And then I put the PMT on the left. I interchange both sides. Then what we get is we have to solve for this here. And again, it's just order of operations. You know, you do the innermost parentheses, you work there first. You do the quotient first, then you add. Whatever you get here, I don't remember what you get, you raise to the exponent, which is 360. Subtracting 1, you basically end up getting all this. This is what we end up getting. So we get $167.65, excuse me, 75 cents. Now this is with the formula okay? I mean, you could, again, use, what do you call it, Microsoft Excel. I mean, you could, type this in one cell, calculate it, type all this in another cell, which will calculate it and then divide. It's good to use. If you can do that, that makes it a little bit easier. Let's also solve this using the TVM solver. Before I do that, are there any questions about this? All right. So to use the TVM solver, we need our parameters, right? So we know that we're going to retire in 30 years, right? And we also have heat, just like we have over here. It's being compounded monthly because we're making, and how do we know that? We're making monthly deposits. And the frequency and the number of deposits in a year equals how many times it's compounded in a year. The interest rate is, 8. We leave that as a percent. There's nothing in there initially, right? Nothing in the account initially. We're looking for PMT. And what do we want? Excuse me, that's what we're looking for, excuse me. We want the account, though, after all this, to have $250,000. So in the future, the end balance, we want to have this in it. Okay. Now, P over Y is 12, and so is P/Y and C/Y, they're both 12, right? Again, they're both 12. There are 12 compounding periods in a year. We're also making 12 payments per year. Okay, so let's go to our TVM solver. Let's go to that. Okay, so let's put all the entries in there. So 30 times 12, what is that? That's 360. See something actually. I don't know if does it all. If you type 30, then if you type 30 times 12, I think it does it for you. We have I, we saw was 8. Okay. PV is 0. Again, there's nothing in there initially. PMT is what we want. So I'm going to leave that blank. You don't have to leave it blank. You just click on this. So FV, again, we want that to be 250,000. Right? That's the balance in the account after 30 years. Both of these are 12. So now let's solve for PMT. Click on it. We get this. Negative $167.74. I know it's negative, but again, the negative just indicates the money is, the money is a cash outflow. It's leaving you. That's what we're saying here. It's leaving you. Okay, that's all the negative is telling us. So the answer would be $167.74, which is what we got from the formula. Okay. Okay. Now, are there any questions about this? So I figured it'd be good to do another, because then we'll start something else that's new. A little bit different than a savings annuity. All right. So now we had a savings annuity, right? That's where you're taking money and you're putting it into an account on a regular basis. A payout annuity is a little bit different. Here, you're taking money out on a regular basis. So the idea here is that you have money in the account. The account is being compounded, okay, at regular intervals. right? So the money in there is earning interest, okay? And also what's happening is we're making regular withdrawals. We're taking money out on a regular basis. And eventually, though, after a fixed amount of time, the account will be empty. You can almost think of this as, this is what happens once you retire. With a savings annuity, that's before you retire. With a payout annuity, this is what you have after you retire. You have your retirement account. You're taking money out of it. You know, this is the money that you live on, so to say. Okay. Okay. Now, there is a formula for it. You know, we're making the same assumptions as with savings annuity. This is the formula, though, you would use. PMT, again, that's the regular withdrawal. PMT, excuse me, is the regular withdrawal here. How much you're taking out regularly each year, each month, whatever. Maybe even each day. I don't know if people do that or not. P0 is the balance at the beginning. That's the initial amount. R, again, is the APR in decimal form. N is how many times the account is compounded in 1 year. That's what N is, okay? N is how many times it's compounded in a year. T, right? That's how many years this is going on for. You know, how long we're making withdrawals for. Okay? We're not going to do an example now, but just like before, though, if the compounding frequency is not explicitly stated, we're going to assume that the compounding frequency, you know, how many times the account is compounded in a year, equals how many withdrawals we do in a year. You know, it's just like what we're doing before. Okay. All right. You know, and also let me just say this. So with a payout annuity, you're making many withdrawals. With an annuity, which really is a savings annuity, you're having many deposits. All right. Next time we'll start from here. Next time we'll do some examples with payout annuity. You could actually deal with that using a TVM solver or the formula. Okay, let me see. I think we have like a couple seconds left. So let's stop. Actually, we're out of time.